Hello guys, today we're going to be continuing our session or series of From OpenAI's Whisper to Your Own In-House ASR service series. Today we're going to be focusing on post-processing and language modeling. And you can see this is our YouTube channel. Please do not forget to subscribe to our channel if you like our videos. And on the right side is our meetup. Join our meetups so you can come every other week and you can ask questions during my recording of these sessions. We do have put the recordings of the part 1 on YouTube. This is the overview, and this is the return on investment analysis, and this is the long audio and the streaming. You have to use your cell phone to scan the QR code to get to the link to the YouTube video. But today will be the post-processing and language modeling, and there will be 3 parts. The first part is the post-processing. So people may ask why post-processing for ASR results is needed. The general reason is people need to go from verbatim to readability. Verbatim, I think, is more related to the spoken language. Readability is more like a natural language or text-based language. Okay, and there will be 2 types of issues over there. The first group of issues is from any ASR system, and there are at least 5 of them, but definitely there are way more than 5 categories. But first, you can see filtering. For example, you want to filter the profanity words. Second, punctuation. Let's eat grandma. Right? You have to get the correct comma over there. And also called the inverse text normalization. You know the famous joke, what's the time right now? 2:22. Casing. You know, I think my friends told me when Adidas wants the advertisement, they always want A to be lowercase. A misspelling correction, like our channel, you may say that it's supposed to turn on the subscription CC option on the YouTube. You will see the name of our company is always transcribed wrongly, like Olewave or Olewave, but indeed you have to correct the misspelling. Okay, why are these things over there? That was because think about the Whisper model or other models trained out of tons of many ASR results, and you can see lots of ASR results. They're not cased correctly. Some of them do not have punctuation and filtering. They're not consistent. Also, the text normalization issues. So this is why you have to use this type of post-processing to regularize your output of your ASR system. And then for the second type of issues, I don't think it's a technical issue. It's more like a philosophy issue, or things happened in the method. How do I? And the second type of issue are more generated by human beings. For example, this English is my second language. I keep thinking about it, right? So I've been using I mean, those are filler words. And also, how about the pronouns? People like to omit pronouns, but in the written language or for readability, you have to put the pronouns there. And also, you want to fix the grammar error. Here, I found an interesting example for you. U is smart. Should you change the is to R? That seems very obvious. But interesting is, it's actually a prompt in the movie that was shot in 2011, The Help. I think the original prompt is it's a senior black lady talking to a small girl. She said, "You is smart, you is kind, you is important." Definitely, you shouldn't change. There's no grammar error here, or that's the special way of Midwest black woman talking to people, right? Okay, and also the first one, and I want to mention that this is why you need to use a context to determine whether you should change any words in the spoken or the verbatim form to the readability or not. And the last one I think is very interesting. It's called substituting with plausible words. For instance, for example, a TV anchor, she said, okay, Columbus discovered America in 1592. That's obviously wrong, right? It's 99% of the time chance that she meant 14, right? You have to change this for readability. And some ASR researchers may argue that ASR is ASR, natural language understanding is natural language understanding. You shouldn't change over there. But I would say that nowadays ASR would kind of have to take on the responsibility of the natural language understanding. So you have to make your ASR output as readable as possible. From OpenAI, it recommends you to do post-processing. It's recommended. How are you gonna do that? They said you should send your prompts and the whispers transcription into GPT. For example, Olewave, right? So you just put, so the prompt would be, there's a company named Olewave, OLEWAVE, and here's a whispers transcription, OLAYWAVE is doing something. Then I think the GPT-4, if it has trained on the text with our company's name, it should be able to, no, it doesn't have to train with our company's name. As long as the prompt has our company's name, it should be recover or correct the misspelling, okay? So this is, the pros is, this is called few-shot learning. You don't need any model training. Any developer can use this approach, even that person doesn't have any machine learning engineering experience before. The second thing is that I think in the previous recordings I have mentioned that Whisper can use prompt, but it can only use the number of tokens up to 224. GPT-4 can take way longer, more tokens than Whisper. I think according to Sam Altman in the recent GPT conference, they said they can take at least 10,000 tokens. But what are the cons? First, calling your GPT API is not good for developers or third-party companies. It increases your ASR cost and latency. Think about when you have finished calling the ASR, you get a result. It's taking time, or it has taken some time. Then you have to send it to another round of calling the API, right? And especially when you have a long prompt, it's gonna be slower too. More slower. Second thing is that you have to spend time on prompt engineering. I think it's related to the third one because those GPT results sometimes they can be unpredictable. It's highly dependent on how you engineering your prompts. I think you may agree with me if you have played with the textual version of GPT. And also, there's no benchmark so far. Let's put the post-processing on the side and let's look at the language modeling, okay? The language modeling for ASR does not equal to the large language model. Why? Let's see, what is ASR's language model? First of all, let's getting familiar with what is spoken language processing. Okay, in my definition over there, okay, it's equivalent to the joint combination of two things. First is the acoustic modeling of audio or speech or voice or sound, plus the natural language processing of text. And before the end-to-end model became sort of state-of-the-art or popular, speech people were using hybrid ASR models, which is a cascaded system of 3 parts, mainly 3 parts, sometimes there are 4 parts. The first part is called acoustic modeling. The second part is called lexicon, or sometimes people call that pronunciation modeling or dictionary or something. And the third part is called the first pass language modeling. And the fourth part may be optional, or the rescoring part, or second pass language modeling. And these, when you have the ASR language model, you have to combine that with the acoustic modeling so they can be jointly used in searching the most likely sentence people have spoken. Okay, I can give you an example. The example is, the great prophet is impressive. So you have to decide whether this is this one or that one. So I give you a vague one, so you cannot determine whether this one or that one, right? So this is why a language modeling is important. It's not only you need to get a, for example, in the past, it's n-gram, okay? N-gram. What's the probability of next word given the past word? And is it all done by counting, okay? Language model is all. So in this sense, it's somewhat similar to the large language model, but there's one key thing. If you are a technical guy, I will share you with one more thing here. For the large language model, when it generates the language model probabilities, it uses the technique called sampling. But for the ASR language modeling, it's not use sampling. It just take the top one best probability. So it gets in the max, not the sampling. Okay, that's the key difference between the ASR language model and the large language models. Where was I? Okay. So this is why you have to have a long context or adjacent context to determine what word you should use here. Because if you look at the acoustic only, there's no way for you to tell which word it is, right? For the language model types, n-gram model is very fast on CPU, but nowadays, GPU is fairly popular. So people are more and more looking to the neural language models, especially the Sora models are transformer language models. And still, because this one is very slow too, right? Many people are using that for second pass rescoring, but there are people using that for the first pass, right? Okay, because they're still playing with the hybrid ASR. And you may say, oh, is hybrid ASR still very old? No. There are lots of engineering systems are still using hybrid ASR. And the only thing different is that in the past, for the acoustic model, people are using the generative model, but nowadays people are shifting to neural network models, which are discriminative model. But end-to-end model is easier to train, okay? And I want to also stress something here is that end-to-end model and the language model rescoring are not mutually exclusive. So you may ask, why Whisper does not have rescoring? Why? Okay, let me tell you the reason here. First of all, data-wise, for the Whisper, because it's used millions of hours of recordings, they have a great amount of transcription or text, so they have a wide coverage of topics, and the model was trying to get a generative, have a general sense of all the topics the data can cover. So I think the model is fairly generic. Doesn't need an extra LLM in this sense. And also latency. like I said, having another pass or having another cascade, having a cascade system slow down your system. But things are changing now because the GPUs are getting faster and faster. The third part is DevOps. According to, if you have watched our previous video about the long audio and the streaming, I explained why Whisper doesn't have streaming. And this is the same thing. If you have, they have the rescoring part, they definitely have to have a dedicated DevOps team to work on the rescoring things. This is too much work for them because their focus is more like on the generative text on the video. The fourth thing might be, okay, I think I'm making fun of OpenAI. I hope that they would allow me to use their Whisper model. But this all four things I talked about here. You ask, well, does that mean the Whisper can just have to stick with no language model? No. Oh, this is one more thing here. This is the most important thing here today. I'm gonna share the one more thing with you. Indeed, we can fine-tune an LLM for Whisper. How do we do this? Like I mentioned, the issues I talked about is Whisper does not perform well on certain topics. For example, medical transcription. Of course, you can definitely leveraging the things they talk about. You just send the whole textbook. Maybe you can, as a prompt to GPT-4, but your bill is gonna be a astronomical number over there, right? And this won't work in the long term, right? You cannot just send a prompt into their GPT-4 every call. They're gonna be happy, but you're not gonna be suffering from the bill. And so what are your or my options? First, I think the final solution would be you can train a joint model of Whisper and the large language models. Don't forget to turn the large language models probability into max probability other than the sampling probability, which means you're going to be getting a large natural language understanding model or ASR model, right? When I say the natural NLU model, I mean you do the ASR and NLU at the same time, or an ASR plus NLP. But this is very sophisticated. It has a lot of math. I won't be able to cover it during our sessions. I think it would rather leave that to the researchers, or if you have a great amount of funding you want to spend, you can patronize us. I'm serious. The second thing is that you can definitely fine-tune Whisper. Like I mentioned in the second part, the ROI analysis. It's actually fine-tune the Whisper is not sophisticated if you have a lot of audio with transcription, or you have a lot of audios with transcription close to your domain specific topic. It's done. But what if, like I mentioned in the above example, is for medical transcription and you only have a textbook, you don't have audio at all. When I talk about textbook, I meant this is a textual domain knowledge. This is not feasible, right? Whisper only takes audio as input. So this why I raised the third part, or third option is definitely doable. This is something called, you can rescore the Whisper's results with the neural language model. So in this case, only textual data is needed. You don't need to fine-tune Whisper. So, but you have to fine-tune a certain type of open source large language models. You ask, wait, can I just fine-tune some smaller language models other than the very large LLaMA models or LLaMA 2? I would say you can. There's nobody blocking you from doing that. But the thing is, you want, because the Whisper model is very big in terms of the parameters, you definitely want to have a very large language model matched to it. Okay. And then if you need technical consulting or you need the topic-specific data, feel free to contact us. We're here to help. I think I'm going to be stopping here. And I want to also mention that we are a data vendor. We help companies to curate customized datasets for training your large language models, ASR models, vision models, or multimodal models. And we are way better than the traditional data vendors. All right, I'll be stopping here. And thanks for coming, and don't forget to subscribe our channel. And thank you very much.